Here's an example of a attribute MSA. We are starting to collect data from one operator in three different iterations. In this case, it is Tom. You can see here in column 3, row 3, Tom does not agree with himself. On sheet 1 he says pass, sheet 2 he says pass, and then sheet 3 he says fail. So we are testing repeatability in this case. We then do the same thing for two more operators, Joe and Paul. Paul's first row, fail, pass, fail, again proves that he does not agree with himself. Repeatability is an issue. We then tally that for each operator. And you can see in the second column it says attribute. Those are the true values or actual values that for those particular things. You can see in column 3 the attribute is a fail, but Tom says pass, pass, fail. So the accuracy to the standard is not there. Paul is passing it when it actually should be a fail. He actually can't agree with himself at all. We do the same thing with Joe and Paul. You can see at the bottom, Paul agrees with himself 53.3% of the time, percent appraiser, and then percent attribute is how often does he get it accurate or agree with this standard or the attribute, and 26% of the time. We then compile the results with all three operators so that we can test both repeatability and reproducibility, as well as accuracy in this case. Accuracy can be done with an attribute MSA, cannot be done with a variable MSA. Here are some acceptable ranges for both continuous data and attribute data for MSAs. In this session, we covered precision and accuracy, the difference between consistency and closest to the target. We talked about the three aspects of accuracy: bias, linearity, and stability. We talked about using a gauge R&R or repeatability and reproducibility study. Repeatability and reproducibility are two elements of precision. And we talked about the difference between a variable MSA and an attribute MSA.